Right, we come to the fourth in my little list of trickier simultaneous equations. And the equation this time is x squared plus 1 times x plus y all squared plus 2x plus y is 135. That's the first equation. And the second is x times x plus y times x plus y plus 1 equals 60. It's equation number 2. Now, the raison d'etre that I've used here is to put x plus y equal to t. So the equations become a little bit more civilized looking, and they are x squared plus 1 t squared plus 2t equals 135, and x times t plus 1 equals 60. There's some firework noises in the background. I hope they don't intrude too much on us. Okay, so now from equation 2, we can get x equal to 60 over t times t plus 1. And we now substitute that into the first equation. So we get this expression here, which is 60 over t times t plus 1 all squared plus 1, and all that is multiplied by t squared, then plus 2t equals 135. The next step is just simplifying all of that, which comes down to 3,600 over t plus 1 all squared plus t squared plus 2t minus 135 is 0. And multiplying up by the t plus 1 squared, we get this line here, 3,600 plus t squared, t plus 1 all squared, plus 2t times t plus 1 all squared, minus 135 times t plus 1 all squared. All right. Now, on simplification, we will get this fourth order equation, t to the fourth plus 4t cubed minus 130t squared minus 268t plus 3465. And we've got to solve that equation. Now, if we look at the constant term at the end, 3465, this factorizes in the following way. That's 5 times 9 times 7 times 11. So let's try t equal to 5 as a possible root. Okay, this in fact does work. So t minus 5 is a factor. And then try t equals 9. This also works. We tried t equal to 7 and it does not, but t equals minus 7 does. And so also does t equal minus 11. So t can have any of the four values, 5, 9, minus 7, minus 11. Now we'll recall the original equations here, that x squared plus 1 t squared plus 2t is 135, and tx times t plus 1 equals 60. Now substitute back into that with t equal to 5, and we will get 25x squared equals 135 minus 10 minus 25, which comes to 100. So x squared will equal 4, and x will then equal to 2, or x will be minus 2. And the corresponding values of y, because they have to add up to 5, will be 3 and 7. Now, if we look at equation number 2 and substitute x equal to 2 with t equal to 5, we'll get 5 times 2 times 6, which comes to 60. So that checks out nicely. However, if we go into the using the other value of x, which is minus 2, we'll get 5 times minus 2 times 6, which comes to minus 60, and it should come to plus 60, so this does not check out. So we only accept the solution x equals 2 y equals 3. Now, to find the remaining solutions, we need to use the values of t equals 9, and then t equals minus 7, and t equals minus 11. The routine is exactly the same as before, so I've left it to you chaps to do that for yourselves, okay? The method is exactly as illustrated for the case when t equals 5, and just be careful that when you get two solutions, as you will, you have to see that it works for both the equations. And if it only works for one of them, then that's the one you accept. And of course, if it doesn't work for both, you only accept the one solution. Okay? That brings us to the end of this little episode. Thank you very much for your attention.